So in this module, we're going to talk about logical structures. I'm just going to introduce them conceptually here, and then we'll do some coding examples in the next couple of videos. So logic in programming is basically the ability to use conditional logic. And this is a key difference between programming languages and markup languages like HTML and CSS, because conditional logic allows different functionality based on a set of conditions. Logic can also be used to perform repeated tasks efficiently. So there are two main types of logical structures: branching structures and looping structures. And most compiled programming languages will have some version of the structures that we're going to discuss in the rest of this video. So let's take a look at branching structures first. What do I mean by that? Branching structure will evaluate a specific value and then take different actions depending on the result of that evaluation. So if you think about it, humans do this too. For example, if it's raining today, I should take my umbrella. That's a very simple statement, but underneath that, there is some rather complex logic. So you evaluate, first of all, whether it's raining, and that's sort of a yes or no evaluation, right? Raining or not. And if it's yes, then you take one action. You pick up the umbrella as you leave the house. If it's no, then you take a different action. You leave the umbrella there. Or you might even think about that as taking no action, depending on how you evaluate that situation. But that's a very human thing to do. We do it all the time. And we're performing that kind of logic in our daily lives just constantly without even realizing it. A computer does the same thing, but it might see this problem in a little bit different way, or at least metaphorically think about the problem in a different way. So this might be a function that would perform the same branching logic that we just went through. So I just made up this function as an illustration of how a computer might parse the evaluation of the weather and determine whether or not an umbrella is appropriate. So it has one parameter, weather today, that it's going to accept in. There's one variable, local variable umbrella, and I'm going to use the branching structure if. So if is a structure, again, super common in compiled languages. It's going to evaluate the weather today variable and see if it is equal to rain. So if in fact weather today has the value of rain in it, then that expression with those two equal signs is going to come back as true. So I want to just point out that two equal sign thing. What that is, rather than using equal sign as an assignment operator, which we've talked about before, and assigning a value, two equal signs is an evaluative expression where it's going to compare the left side to the right side and return either a true or a false. So it just has those two positions. If those two things are equal, true. If they're unequal, false. Okay. So if it's true, and that's how ifs work. Only if a true is returned for the conditional expression does it do the thing. So if it's true, then we're going to set the variable umbrella equal to true, meaning take the umbrella. Otherwise, and that's where the else comes in, otherwise we're going to set umbrella equal to false, and then in our fictional function here we're returning the value umbrella, which conceivably would then take some other contribute to some other action taken by this program. So that's just, again, a hypothetical function just to show you how a programmer might step out this logic to perform the same kind of evaluation. So it's a different syntax, definitely a different syntax, but basically the same logic. Okay, so what about looping structures? Looping structures repeatedly evaluate a condition and perform a set of actions until the terminal condition is reached or until the evaluation changes. So you have to be careful with looping structures. A little caveat here, though. You can create an infinite loop by accident, like we don't create infinite loops on purpose, but infinite loops will infinitely hang up your program. So you do not want those, and we'll work on steering clear. But again, just in your debugging, that is one thing to look for. If your program just seems to hang up and stop working, check your looping structures. That could be where it's hung up. So again, as humans, we do this too. We work this way too, except we don't probably do that infinite loop thing. In this case, it might be something like, I'll use my umbrella until the sun comes out. So you're continually evaluating the weather conditions around you until they change. And then when you detect that change, that's when you're changing your behavior. That's what a looping structure is, as opposed to a conditional structure, right? Conditional structure, you're coming in like having taken no action, and you're deciding on an action based on an evaluation. In a looping structure, you're assuming that you're going to continually be taking an action until something changes or until you get to the end. As I said, the terminal condition, that just means you are going to do this maybe 100 times and you hit 100, so then you stop. And so there are a couple different looping structures, one that has that finite limit to the number of repetitions, and the other that just waits for some change. So you have to make sure that you've got that change detector built into your loop. So this is a function that we might write to express the logic that I was just describing. In this case, I have the function use umbrella rather than take umbrella. Still passing the parameter weather today, still creating the local variable umbrella, but we're going to use a different command, while. And while is a looping command. So while weather today is equal to rain, so that same thing there, right? We're still doing a true false here. Then as long as it remains equal to rain, then umbrella is going to be equal to true. But unless we do some work within that loop to check the condition and see if something's going to change, we'll never get out of that loop. So it's really important to have that next line of code where we're going to set weather today equal to check weather. And check weather is some other user-defined function that goes out and somehow checks the weather and returns a value. And so that value will be either rain or some other thing. And when that value changes to some other thing, then that loop is going to stop. So every time the computer goes through and hits that line of code, weather today equals check weather, it goes off into that other function, gets that value. And then when it loops back up to the while statement, if weather today now suddenly has a different value, then it's going to skip the rest of what goes on in the while statement and go to the next line of code. And the next line of code will be umbrella equals false. So I'm sure you've noticed some of the syntax features of these logic structures, the way they're using squiggly brackets, parentheses, the double equal sign to get our Boolean evaluative conditions. And then inside, the algorithms are what we've been seeing in our functions otherwise. We'll get into that in much more detail in the next couple of videos where we actually do some coding. But that, I just wanted to conceptually walk you through the difference between these two kinds of logical structures and to help you start to understand when you would use them, what kind of situations you would use each one of those in, and how they could be useful in your coding.